Stan Jabalisco here to talk about the most preferred and most efficient way to get full wave rectification of alternating current. Here's the alternating current input to a transformer. Here's the transformer secondary, and here are 4 diodes arranged in a configuration called a bridge. Now notice the directions of these arrows, the orientations of these diodes. That's very important here in order to get positive here and negative here. So let's talk about current as a flow of electrons and talk about what happens when current tries to flow, or flows actually I should say, from the bottom to the top in this secondary. That's half of the cycle. That's what's going to happen. Electrons are going to flow through this wire like that, and they're going to hit a branch point. They're going to have a choice between this diode and that one. Electrons cannot flow with the arrow in a semiconductor diode, but only against it. So they will flow through this diode and on out through this wire and out of the negative terminal. So we will get electrons flowing like this. Okay, that's cool. That's that half of the cycle. Now let's see what happens when electrons try to flow from the top to the bottom in this secondary winding. They'll flow through this wire, they'll come here, and they'll hit this branch point, and they'll have a choice between this diode and that one. If they go through this one, well, they can get through this one, they can't get through that one, so they're going to go through here and again, out through the negative terminals. So we're going to get negative pulses in both halves of the cycle. Now let's talk a little bit in reverse here about electrons moving away. Maybe what we should do is turn around and talk about conventional current that moves from plus to minus. So we can imagine of some kind of anti-electrons that go from plus to minus. So let's just imagine that. You know, this is kind of a weird scenario anyway, but these anti-electrons rather will be able to flow out of here. So when we have the anti-electrons flowing up like this through this half of the cycle, they'll hit this branch point and they'll have a choice between this diode and that one. They won't be able to flow through this one because anti-electrons can only flow with the arrow in a diode. So they'll flow out through here like that, and we'll get positive anti-electrons coming out of here during that half of the cycle when current tries to flow from when anti-electrons try to flow from the bottom to the top. Now when they try to go the other way like this, they're going to come around, they're going to hit this branch point, and they're going to have a choice between this diode and that one. But remember now, these anti-electrons do exactly the opposite of what electrons do, so they can only flow with the arrow in the diode, and they'll flow along out through here and create positive pulse here. So that is what will happen in both halves of the cycle here. We're going to get anti-electrons flowing up like this, out through this arrow like that during that half of the cycle. Electrons flowing down like this during the other half of the cycle. They'll be able to flow on out and again through there. So it works. We get positive pulses here and negative pulses there. Of course, there's no such thing as anti-electrons unless you're talking about antimatter. Maybe an antimatter universe, the positrons would flow with the arrow in a diode and not against it. What would we ever do? You know, I mean, we'd have to learn everything all over again. But that's the full wave bridge rectifier circuit, and it is a better way than the full wave center tap method because it makes more efficient use of the transformer, takes advantage of the entire secondary winding on both halves of the cycle, so it's easier on the transformer. It can use a simpler transformer that's less expensive. It uses 4 diodes to share the current burden, which makes it each diode only have to work half as hard as they do in the full wave center tap configuration. So that's the full wave bridge rectifier for you. And you'll find this and related topics described in exhaustive detail in my book, Teach Yourself Electricity and Electronics, a link to which I will include in the description of this video. Stan Gibilisco signing off. Until next time, so long.